to let you know. If we have a couple of new people here, like to introduce themselves before we bring on Mario. I guess we have Bob. You want to say hello, Bob, and tell us about yourself?
Hey guys, I got into astronomy when I was flying and going across the Pacific and the Atlantic at night, wondering where the world everything was. And so I bought a Meade LX200 to start out. I bought it just before the comet hit Jupiter, and had some great viewing there. And then work just kind of got in the way and let it go a little bit. Finally decided to sell it, and the guy I sold it to said it never worked once since he owned it. So he gave it back to me. And Tony now is working on fixing the boards and motors and whatever. So hopefully I'll be back in business here in a week or two.
Yeah, I sent you the email. It survived the operation this morning. So
yeah. And I got a granddaughter. She's only just 3 years old, but I'm getting this thing going again because I'd like to get her excited about this sort of thing too. So
very good. We also have Mike Wheeler. Mike, this is the first time you've been on. It's great to see you, my friend. You want to introduce yourself?
He's muted.
He's muted. Let's see. Ask to unmute. Well, there he goes.
I don't know if it's my fault or not. This is Bob again, but I've got this banner in front of the middle of the screen that says it's being recorded by a host or participant.
Yeah, me. That's me. And we're recording this.
It won't go away. Is there a way I can get it to go
No,
away?
yeah, just hit got it. Just punch got it.
Oh, okay. That wasn't showing. Here we go.
All right. So other than Mike Wheeler, Mike, are you on? Can you hear me?
You ready?
I want you to introduce yourself. No, all right. All right, so we're gonna talk. I'm gonna have Mario discuss the aspects of light pollution and how they affect us as astronomers and how they affect our health. So I've known Mario for at least 40 years. He's a member of the ATMs of Boston, former president of the American Medical Association, and he's down here in
No. Former president of the Mass Medical Society. I was a trustee of the AMA.
Okay.
Okay, but I was never president of the AMA.
Okay.
So
Sorry about
you
that.
can't promote me on your own.
Oh.
I think it's just wonderful that you're here and have promised to fix light pollution for us.
Yeah.
Well, you did do a lot of work in Massachusetts to get some laws passed, didn't you, Mario?
Yeah, we have about 60 cities that have light pollution laws, but we one of the few states that still hasn't passed one, and it's because we have a dysfunctional legislature, even though there's no opposition. What can I say?
All right, Mario, I'll turn it over to you. Take it away.
All right, so you want me to share screen?
Yeah, let me do the share.
All right, let me open up my PowerPoint here. Excuse me.
It went away. The audio went away. I'm gonna hold up there. The guy that's fixing the
All right.
telescope electronics
So
set me up.
I'll
with
try
a
sharing
Zoom
now.
call that he does every Thursday with somebody of the business, the hobby.
Hey, Bob, can you mute yours perhaps if you're going to talk?
I got him. I mute him.
All right, can you see my screen?
Yes.
Okay, so I've got quite a number of talks actually on light pollution. I'll give you the one I gave after being involved in a UN committee on light pollution after a 2-year effort. It's pending in front of their CUPOIS committee, which is anything to deal with outer space. And I was specifically asked to represent the AMA at this committee. So you already said who I am. I don't need to show you this slide. What's that? Was there a question there? I heard someone talk. All right, so I've been working on light pollution since 1989. Initially, I was interested because of astronomy, to tell you the truth, but I was a researcher at the time, and I came across a Richard Stevens, who's an epidemiologist at University of Connecticut, or was. He died 2 years ago. And he was the one that first proposed that suppression of melatonin is a cause of increased breast cancer. And at first, it was just an epidemiologic approach, but he based his data on the fact that in China at the time, which was not light polluted, had an incredibly low risk of breast cancer compared to the US and most Western countries. And he used that specifically because China is incredibly polluted with toxins and air pollution and water pollution. And at the time, people in the US were trying to blame that for breast cancer that is beyond the BRCA gene, that genetic cause of breast cancer. And he said, look, the most polluted country in the world has a lower rate, yet people, when they live in China and move to the US, suddenly developed a higher rate. So what's the difference? And he put 2 and 2 together. He is an epidemiologist and said it's probably melatonin suppression. In the past 40 years, thousands of studies have been done, and he's essentially been proven correct. This, by the way, is my observatory back in Gloucester, back into my house. And that's my scope. It's a 32-inch f6.5. It's a relay scope. And here's a picture I took a few months ago with it, 891. So I already spoke about Richard Stevens, but so how does light pollution affect human health? It interferes with circadian rhythms. That's pretty obvious. Melatonin suppression inhibits the immune system. I'll talk a little bit more about that. And because of that, you have endocrine-related carcinomas increase. Specifically, that means breast cancer in women, prostate cancer in men, thyroid cancers in both, and a few other lesser-known carcinomas have been shown to be increased. It's obviously related to sleep disturbances. It has a link to possible childhood leukemia. I'm not sure the mechanism on that. Glare on roadways, and we lose our natural environment at night, which is probably why most of you are concerned with it. But it's more than just losing the natural environment in the sky. It's toxic to the environment for animals. So what is melatonin? It's a hormone produced by the pineal gland, which is dead center of your brain. And it's suppressed in daylight, and it rises at night when you're asleep. That is, it rises at night when you're asleep if you don't have light pollution in your bedroom. Okay, and we'll talk more about that later. So around 2003, 2003, and this is a paper published in 2006, this new receptor in the retina was found called RGC. And it's a cone, but that has nothing to do with vision. So we have red, green, blue color receptors in our fovea, in our retina, that allows us to see color. We have rods that allow us to see black and white at night. And we always thought that there were those 4. Well, this is a new one that's been discovered that has nothing to do with vision. It does not travel back. You can see my pointer, right?
Yes.
It does not travel to the vision center, which is loaded in the occiput back here. Instead, these fibers go directly to the pineal gland and the limbic reticular system. And why is that important? Basically, this cell is in the peaks in the blue. So when it sees a bright sunshine in a blue sky, it suppresses the melatonin production and it stimulates the reticular system, which basically wakes you up. That's great in the daytime, especially if you live in caves and you need to know when daylight was occurring. It's bad in modern society when you have light pollution interfering in your sleep in your bedroom, and it takes surprisingly little to do that. So it turns out there's quite a bit of variation in how sensitive we are, like everything else. Here's a study out of Netherlands where they've shown the variation in human testing. So some are extremely sensitive and some are not as sensitive, but everyone is affected by light pollution. What's the problem? Here's the problem. This is a blue LED. There's no such thing as a white LED. If one of you can figure out how to make a white LED, you'll become instantly a billionaire. But many have tried and cannot make it. LEDs tend to be monochromatic. So how do you get a broad spectrum light as opposed to a single wavelength? You take a blue LED, you coat it with phosphors, which were difficult at first. Now it's cheap to do. The phosphors re-radiate the light from a high intensity to a lower intensity light, and you get the broad spectrum light that you want. That's how you make a white LED. Problem is the blue shines through the phosphor. So even though you think you're getting a white LED, you're getting quite a bit of blue, and that depends on the manufacturer. So you have the old high pressure sodium with down here. Amber is perfect, doesn't give you any blue. And what you want is color over here at nighttime. Blue is something you want to try to avoid. And here's a set of lights. It's hard. They all look white if you look at them individually. The eye adapts to what it's seeing. But a 6,000 K LED, by the way, the surface of the sun is 6,700. So these are absolutely be avoided at night. 2,700 is what I propose now, or amber, which is no blue. Even the 2,700 produces about 15% blue. 3,000 about 21% blue, and 4,000 about 35% blue. But when you see them side by side, you can tell the difference. And I've trained myself so I can look at a light bulb now and give a pretty good estimate without a light meter what it is. So what's the problem? If you go follow the red line, this is useful light. It's in the red, yellow, green, and that's what you want for a street light. And it doesn't give that much blue because the light's been captured and re-radiated lower. But even with those, you get a percentage that is in the what I call the melatonin suppression zone, which is the blue. But if you look at a 4,000 K LED, which unfortunately a lot of light companies push, including Florida Power and Light, they are stubbornly insistent on 4,000 K lights. Between Florida Power and Light and Duke Energy in North Carolina, those are among the two worst providers in the entire country. They are oblivious to what they're doing. But the 4,000 K LED has a huge amount, 35% or more of blue light. And that is bad at night. So in Gloucester, where I live, we, way back in 2012, got them to switch out their lights. They was going to switch them anyways, convinced them to use 3,000 K lights. At the time, that was the best available. Now I would recommend 2,700. So we got 3,000 K lights, but second importance is the amount the intensity of the light and the fact that they got to be shielded. These are shielded. These are 19-watt LEDs. One of the problems which city managers who know nothing about lighting, and they defer to the lighting company almost always, is you have a 60-watt high-pressure sodium, which is typical of what secondary roads had. Main roads tended to have 120-watt high-pressure sodium. And the lighting company says, all right, we'll give you 60-watt LEDs. If you don't know any better, you say, okay, great. The problem is there's a 4-to-1 conversion ratio. So if you have 60-watt LEDs, high pressure sodium, and switch to 60-watt LEDs, you're getting 4 times as much light. So in effect, you've now increased the amount of light by a factor of 4, and you got the same as if you had a 240-watt high pressure sodium, which we definitely don't want outside your bedroom window. So those are the 3 things you got to watch if you're going to push for replacements. One is the CCT, the color correlation temperature. 2, whether it's shielded or not. And 3, what the total wattage is. You want to divide by 4, and that's the wattage you should get if you're going to do a direct replacement. And many replacements fail on one of those 3 simple things. So here is a typical 90-watt LED. This will blind you. It's hard to look at. These are the kind of lights that you want to shield your eye, and they cause accidents because of the glare. But this is what is being sold as lighting for our streets. This is an image I took of M81. All right, so let's talk about the human eye. From the outside, you can see a pupil. And when you're young, it can dilate to 7 millimeters. And the purpose of that is so you can see at night. In bright sunlight, it'll shrink to 1 millimeter. Here's a problem. At night, it should be dilated so you can see well down the road. If you're exposed to bright LEDs, it's the same as if you're looking at the sun. The pupil shrinks. So now you got a 1 or 2 millimeter pupil, and everything looks dark except under that light. And of course, the typical business owner's response to that is add more light so it doesn't look dark. The typical city council member response to that is let's add more street lights. What you got to do is shield the lights, let the eye function as it's supposed to at night, and you don't need as much lighting. A simple concept that unfortunately is lost on too many people. As you age, the center of the eye deteriorates. The lens of the eye has no blood supply. That's important because otherwise it would interfere with vision. So it gets all its nutrients, oxygen and sugars, through diffusion from the surrounding aqueous humor. The problem is it grows like an onion as you get older, and eventually it becomes so thick that the diffusion to the center of the eye isn't sufficient. When that happens, the cells at the center of the lens start to die because they don't get enough nutrients. And when that happens, you get any cell that dies calcifies. It's just the body's response to a dead cell. And then you end up having microcalcifications which cause scatter, and eventually they coalesce to form a cataract. That's why most people in their 40s start having mild vision problems. As it calcifies, it doesn't accommodate as well to near and far vision. So it calcifies, stiffens, it causes scatter, and that's why older drivers have a worse time driving than young drivers. And what I tell a lot of, when I speak to engineers and older people, is if you're having trouble driving at night, it's not your fault. It's damn engineers who have no idea what they're doing. And that's true. If it was engineered properly, you'd be able to see. So in France, they've actually outlawed direct light to make the lighting better on the human eye. Once you get above a certain amount of what's called nits, the way they measure it, it becomes painful. If you don't believe it, stare at an LED light straight up under it, and you eventually will have to shield your eye. It starts to actually hurt the eye. And here is an example of what I'm talking about. So we all know the sun turns red as it sets, right? Why does it do that? It's because blue scatters in the atmosphere. And when the sun's setting, you're going through 5 or 6 atmospheres worth of light. And the blue completely scatters out. That's why we have a blue sky, because the blue scatters. The red, yellow, green gets through straight up. And by the time it sets, only the red gets through, the longer wavelengths. So this is a human eye testing to see how much scatter there is in the eye. He took human eyeballs from cadavers. Now, this is a log scale, so the difference between these is much more than what it appears here. Okay, so in a human eye, the red penetrates more, the blue scatters the most. Simple physics, exactly what happens, and it scatters more as you get older because of the microcalcifications, which is why in older people, when you're 20, it takes 1,800 Lamberts to cause what we call disability glare, making it dangerous to observe. By the time you're 60, about a third of that, down about 400 Lamberts, causes disability glare. We have a lot of 60-year-old drivers. We shouldn't be designing streetlights so it's dangerous to you. So here's an example of what I'm talking about in terms of glare. This I borrowed from a friend in Quebec, conference I went to in Sherbrooke on, what was that meeting? Artificial light at night. So here is a typical installation. You have a street light indicating there's a turnoff coming up. They put a light there. Can you see the turnoff? No, because your eye, just like a camera lens, is contracted, so you can't see down the road because of the bright spot, which makes it even more dangerous if there's someone standing there. This person here moved forward exactly 6 feet. So you go from completely invisible, like a deer would be or an animal in the road, to visible only when you're in the direct light of that street light, which is why street lights are bad at intersections, because you can't see beyond the damn street light. So across the country, LEDs were invented, and they're a good thing because they use less fossil fuels and energy. No question about that. But you need to put in the correct ones. So Queens, New York, I think it was 2012, 13, started putting up 4,000 K lights in Queens. And this is what they look like. And they're harsh. Okay, in the New York Times put it, it looked like an authoritarian LED streetlights, meaning it looked like a prison. And that's what people thought. This is what a typical homeowner, apartment owner, with the lights streaming in their bedroom. Okay, people hate them. One thing I've learned is a lot of people don't understand the difference between 4,000, 3,000, 2,700 streetlights. But once they're outside your door, you know you hate them. That universally people hate these lights. Unfortunately, once they're up, it's hard to do. One of the things the lighting companies say, well, you need them for color rendition. The red line is 1,870, which is high pressure sodium. We lived for 40 years with high pressure sodium without any problem whatsoever. No one raised a peep about color rendition. The black line is 2,500. The color rendition between that and daylight is negligible. Okay, so I was involved in a debate with one of the lighting people in California about 4 or 5 years ago. And at the end of the talk, he made this stupid comment. Well, if you push for 3,000 K, which by the way is green here, push for 3,000 K, is the AMA going to be responsible for all the traffic deaths that will occur? So I pointed out to the audience and him, we've lived with the lighting industry having 1,800 all these years. Are you responsible for all the deaths from traffic accidents for the last 50 years? and he just shut up and the audience clapped. Easy way to shut them up is give them facts. And detection distance, another thing the lighting companies will say, well, you need the higher LED in order to see better. There's no difference in distancing, and this is from Ron Gibbons at Virginia Tech and Alan Lewis, a former president of the Illuminating Society of North America, that there's no difference between 2,100 and 6,000. The difference is negligible. The only time it makes a difference is if you're looking 21 meters off to the side of the road. But you should be looking down the road, not what's happening in people's yards. So this is also negligible. So when it's studied, their argument completely falls apart. Another thing you'll hear, well, the moon is 4,100, and so we need 4,100. I mean, the moon doesn't cause problems. This is an actual spectrum of moon. Okay, and here in the violet, you see it's not much. So the blue line is the actual spectrum. Here in black is a spectrum of a 4,000 K light. Notice something different? They talk about this part matching, and they never like to bring up the fact that there's this huge blue spike that they like to ignore because it underscores their argument. So whenever some engineer brings up that BS, I bring up this slide and say, well, explain this if you say they're the same. And again, facts get them to shut up because they can't defend themselves. So here is a 2,700 K LED in Gloucester. Looks perfectly fine. Okay, colors are fine with that. You can say green is green, black is black, yellow is yellow. People prefer the warmer colors. They don't want to live in a prison-like atmosphere. In fact, it's gotten to be Davis put up 4,000 K lights. There was so many complaints that the town, they finally held a meeting to say, well, you'll have to spend money to replace them all. Davis actually voted taxpayers at a meeting to spend $350,000 to replace all the 4,000 K. They raised their own taxes because they hate the lights so much. When have you heard that? Monterey sued their own city because they put up bad lights. Seattle, 4 years ago, after putting up 4,000 K lights in 2010, due to the number of complaints, finally started replacing all their 4,000 K lights. They're putting up 3,000 K in main thoroughfares and 2,700 in neighborhood areas. Pittsburgh just last year voted to replace all the 4,000 K lights. So what I tell people who are interested, don't let them make a mistake. Learn from other people's mistakes. If the lighting company suggests 4,000 K, say no, because we'll just have to replace them in a few years. That's the argument for the city councils. So here's a number of cities have now demanded 3,000 K, some of the biggest cities in the country. One, Toronto, even said they demand AMA compliant lighting. And here's a number of states that have light pollution laws. Florida is not among them, but neither is Massachusetts. Okay, people prefer warmer lights. They're less harsh. This is my view of the Trifid Nebula. So let's get into the cancers and other issues. That was all about the glare and reasons why you should have 3,000 or lower for glare. Light at night alters hormones, suppresses melatonin. So if you accept that, you should, and that causes human health issues, you would predict shift workers, people who are constantly changing their time, like nurses working at night or daytime, would be at higher risk. Multiple studies have shown that's true. Blind women would be at lower risk compared to non-blind women, including twins. There's an incredible study. I don't know how they managed to catch these worldwide study where they found twin women, one of which was blind, one of which wasn't, but they're twins. Okay. After following them for 30 or 40 years, apparently the ones who were blind didn't develop breast cancer. The ones that were, a percentage of them developed breast cancer. I don't know how that study got done, but it's a published study. Lighted bedrooms at night increase risk. That's true. I'll show you some studies on that. And proper amount of sleep lowers risk. The international, what's the A for example? I'm sorry, I'm blocking on what the letters stand for, but it's a UN committee, how they rate levels of risk. Okay, it's group 1 is definite carcinogen, no studies needed. That's like if you inhale benzene, you're going to come down with leukemia. That's a known risk of benzene, and which is why it's controlled. And when it spills in the environment, there's a problem with neighbors. Group 2A is probably carcinogenic to humans. That's the same risk of tobacco smoke. Okay, and yet we don't doubt that tobacco is bad for you, but it's still listed as a group 2A because you got to follow people over a long period of time, and only 1 in 3 who are exposed get lung cancer. So probable carcinogen. Well, turns out melatonin suppression is group 2A. So the IARC has classified shift workers and melatonin suppression at the same risk level as tobacco smoke. Let that sink in. So faced with that, in 2009, I was on the Council on Science and Health of the AMA. I was on that committee for 8 years, and we got a resolution passed that lights should be fully shielded. There was no pushback on that. That's just rational sense, right? 2012, due to all the studies, and at this point we had like 20 years of studies that showed lights are bad for you at night, published a paper. It's about 30, no more than that, what am I saying? Yeah, it's 38 pages and has 113 peer-reviewed references. You can't get anything passed by the AMA unless you have peer-reviewed data, meaning it's been studied, it's been sent to independent reviewers at known experts at various academic institutions, and everyone agrees that it's real. So this got published, and these are the people who helped me publish it. My name's there, but I was basically a glorified editor. These were the real researchers. Okay, Blast from Tulane, George Brainerd from Thomas Jefferson. These are world recognized, and they helped me write this. And it basically said that we should limit excessive light at night and prevent circadian rhythm disruption, not just for us, but for the environment because of animals that live outside. That actually went through fine. Got adopted unanimously, remains AMA policy. Here is one of the first cancer journal articles on circadian rhythm disruption. My name's on it as well. 2016 came around. I don't know if you guys remember, but that was when LEDs really had a major breakout. The lighting companies were going to change basically all the lights in the country to high CCTs. Now, at the time, there was a slight difference in cost between 4,000 K lights and 3,000 K lights. Not much, but a slight difference. 80% efficiency versus 92% efficiency then. Since then, the efficiency difference is 92 versus 94% efficiency, negligible, and there's essentially no cost difference nowadays. But while this came out, we came out with this report at the time because Chicago and many other cities were going to start replacing all their high pressure sodium lights with 4,000 K lights. So we published this paper through the AMA and became AMA policy that we advise cities not to do that they should use 3,000 K or less lighting because of human health effects. Okay. And basic, here it is, 3,000 or lower. Notice or lower. Many engineers keep saying it's AMA supports 3,000. No, 3,000 or lower, so we could plan for the future when better lights became available. So the lighting industry had no problem with this. Basically, we support LED lighting. Had no problem with this, minimizing lowest blue as possible. But they went ballistic over this. Okay. After this got published, the lighting industry sent the AMA and me personally threatening emails. I kid you not, I saved some of them, basically saying, you're a bunch of doctors, we're the engineers, you have no idea what you're talking about, stay in your lane. It's kind of like the gun industry to the AMA when we propose stop putting bullets in our patients. You know, stay in your lane, you don't know what you're talking about. And to the point where the lawyers at the AMA said, should we have a sit down with these people? And we hashed it out a bit. And finally I proposed, well, they're claiming our 126 peer-reviewed papers don't mean anything. Okay. So why don't we just send them a letter saying, give us your proof that what you're saying is correct. Okay. In other words, we'll compare papers to papers, and then we'll be happy to have a meeting with you. So we sent them that note. To this day, no one in the lighting industry has sent one paper that indicates anything of what they're saying is nothing but BS. And we still challenge them. If you think you know what you're talking about, send us a paper showing that you peer review paper that says that's been studied and demonstrates that what you're saying is correct. They have none. Okay, it's been 5 years. They can't send a thing. So after we sent them that letter, they kept blustering, but without any counterbalance to that. Our position stays the same. The IAS this past year, finally, in their latest, in fact, their annual meeting this year is on health, using healthy lighting, which is a complete 180-degree turnaround from 5 years ago when they were threatening us. I'll give you one of the reasons why they were so mad back then. You've heard of Siemens Lighting?
Yes.
Okay. Siemens thought they were going to basically conquer the US and make billions of dollars in profit. So Chicago, just before this, as this came out, had a contract ready to sign with Siemens. They were going to place all 275,000 streetlights, high pressure sodium in Chicago, with 4,000 K lights. This came out, and because the AMA is based in Chicago, Chicago City Council wanted to look at it. They actually put this aside and did their own studies with academics across the country as to what they should do. Because the lighting industry says, we have these lights, we're ready to go. After 3 months of their own study, they came out and said, you know what, the AMA is right. We want 3,000 K lights. Because of that, Siemens lost a $1.1 billion contract to another company that was going to provide 3,000 K lights. To this day, if you mention my name to Siemens, you'll likely get a string of swear words. Okay, they still hate me. So you may say, well, does the rest of the scientific industry support that? To 2017, the Nobel Prize in Medicine went to Hall, Rosbach, and Young for delineating the biochemical pathway of how melatonin works. So at least the Nobel Prize thinks this is important. And here is their mechanism, how melatonin gets suppressed and what it does in the cells. This is my image of the horse head. So after all that, the IAU, the International Astronomical Union, and Spain, you have to have a country sport thing, proposed that we have a study on dark and quiet skies for science and society. It wasn't just about light pollution, it was satellite proliferation. There were 5 parts to this. I was asked to represent the AMA at the light pollution part. It's a 2-year effort. So it was to protect astronomical observatories, because even remote observatories were being threatened. Satellite constellations, which is an ongoing problem, as you know, Elon Musk. Protection of radio astronomy. protection of dark sky oases, which are rural places that have been designated as dark sky, and light pollution in the bioenvironment. They were supposed to have a meeting in La Palma on the Canary Islands. The first meeting got changed to Zoom, unfortunately, because of COVID. And the second meeting the following year, we were all set to go. I had my tickets and reservation. And 1 week before the meeting in 2001 in November, the volcano erupted 1 week before. So everything got canceled and had to go to Zoom. So I've never visited La Palma, which is really annoying to me. These were the people worldwide who were involved in dark and quiet skies. My name's here. And here are the people on the light pollution researchers from around the world. So here, I'll give you a brief summary of what I said, because that's pretty much what we're going to talk about with light pollution. So sleep research, the nighttime sleep duration has an effect on hormonal cancers. That's unequivocal. Multiple studies have shown that. Circadian clock, 10% of all our genes are controlled by whether your pineal gland is working correctly. 10%, 1 out of every 10 genes. So it shouldn't come as any stretch of the imagination that if you disrupt that, there are going to be consequences. There are many of which we don't even know about yet, but there are going to be consequences. So circadian disruption can affect cancer, breast and prostate, and others. So I would add thyroid cancer to that now. Obesity by altering leptin and ghrelin. Multiple studies have shown that if you live in a light polluted area, you have a greater chance of becoming obese, which increases diabetes and glucose metabolism separately, and mood disorders, depression, bipolar, increases in light pollution. So I already actually discussed that already. So here is one of my favorite studies. This was done by Blask at Tulane. David Blask is a researcher. He works with lab animals to determine how light affects growth. And so what he did is he took the nude mouse model, and that is a animal that's been bred to accept transplants and not reject them. Okay, the reason you got to do that is you can't take a couple of thousand women and break them into cohorts and test them the same way. Obviously, there are ethical issues with trying to induce cancers. So in this, he took 20 lab rats at a time and put human breast cancer under their skin. And there was 6 cohorts, so 120 animals. And then did something unique. With this cohort, he had a day-night cycle with night being dark. And here's the rate of breast cancer in those mice. Then the next one, 0.02 microwatts per centimeter squared, which is basically a tiny nightlight. And the rate of breast cancer noticeably increased. Then 0.05, which is slightly brighter nightlight, increased cancer growth. So finally, when it went to constant light, the poor little mice, the breast cancer basically exploded out of their chest in rapid growth. The only thing different between these mice was the amount of light at night. Okay, this is one of the first studies that definitively showed cancers grow faster when you have a interfering light at night. It's a landmark study. So what about humans? So here's a study that came out of Harvard in 2017, and it involved 110,000 women, called the nurses study because they followed nurses. And they did it not just for breast cancer, but basically a number of studies. And they followed these women over more than 20 years. And what they found, they divided up, for this part of the study, they divided up women based on their zip code and satellite data, where they lived in the center of a city, further out in a suburb, further out in a further suburb, or out in the rural area. And it turned out that the women who lived in light polluted areas, mean nothing else changed. in terms, they were all randomly assigned. Nothing else changed in terms of their health habits. They were randomly assigned. The only difference is the amount of light pollution. And in the center of a city, light tends to come into your bedroom window. In a suburb, it does too if you have street lights on your street. It turned out that the amount of breast cancer increased from the lowest light polluted areas to the maximum light polluted areas by about 15%. And that was a very stepwise increase, just like that rat study with the light at night. It mimics it almost exactly. Since that, multiple studies have replicated this study. So we got, I think, 20 studies now that all say the exact same thing. Most recent is one from Spain. Okay, same result. They claimed 17% increase. One from two from Israel, one from Connecticut, just in that state. Another one was a worldwide study. Another one was from South Korea. The key is, in all these studies, between 13 and 17% increase in breast cancer, depending on whether you live in a light polluted area or a non-light polluted area. Okay, once you have 20 studies that say the same thing, it's pretty well proven. This is, which one is this? This in Aquila, but I'm blocking on the number. But anyways, it's a planetary nebula. Okay, so pretty well clear that it affects human health in multiple ways. Let me tell you why it's bad for the environment. And this is how to get neighbors involved too. Even if they don't, it's never going to happen to me. I'm not worried about light cancer, breast cancer. But many people are worried about turtles and insects and things like that. Travis Longcorp is a researcher from California who's done multiple studies, and the others are Europeans. So it affects plants, insects, birds, fish, even invertebrates and plankton. I'll show you all that. In fact, there's a great, from Nature in January 2018, Travis wrote a great paper. And here's his last line in the paper, which I quote: "If a lighting environmental effect on a particular species has not yet been documented, it's probably because it has not yet been studied. In every single case where a study has been performed, an effect has been determined." Basically what he's saying, every time he studies a species, light pollution affects it. So if it's not listed as affected, it's probably because it hasn't been studied yet. His conclusion is every animal on Earth is affected by light pollution. Now, here's part of the problem. Blue, because we know scatters, blue scatters and spreads further away than all the other wavelengths. So if you have street lights that are producing a lot of blue, it can travel 50 miles laterally. Blue light's bad for the wildlife. We know in Florida, in the East Coast, they were losing all the turtles. They were all dying off. And people in Florida must remember that, right? And then Atlantic University, a researcher there, I'm blocking on his name right now, everyone kept saying, well, it's got to be pollution and all that kind of stuff. And he did a simple study and found, no, it's the lights. People in the East Coast love to, Boca Raton, love to shine lights on the beach all night long because it looks pretty. Well, the problem is when turtles hatch at night, they're genetically programmed to go to the brightest light. Normally that's moonlight. That's why they tend to hatch during full moon. But if you have street lights or porch lights in the other side, they never go to the ocean. They go to the street and they die. Once they pass some laws to limit beach lights now, and the turtle population's coming back. Had nothing to do with other pollution other than light pollution. Kills birds. How many people have seen lightning bugs? They're pretty much going extinct anywhere near humans. And the reason is, quite simply, if the male lightning bug can't see the female lightning bug and vice versa, they don't mate and they go extinct in that area. So, I already talked about sea turtles. Vertebrates, 28% are affected. This is severity, all affected to one level or another, but 20% severely affected. Invertebrates, bats, amphibia, insects. Right now, 40% of all insects that we had 30 years ago are dead. Okay, I went to a conference where one of the entomologists was giving a talk, and his title of his talk is telling. It was, "Why is your windshield clean nowadays?" And basically what he was saying is 30 years ago, you drove in the road, you'd have bug splats on your window. Nowadays, if you live anywhere in an urban area, it doesn't happen. Why? Because we killed them all off. So, lights, people seem to like to light up bridges. The problem is it creates a zone where fish like to avoid. Here in Northern California, someone had a bright idea. Let's put up these lights on the door. It had nothing to do with safety. It doesn't shine up here. And they followed rules so it doesn't shine in your eye when you're driving, but it shines down into the water. So you could see it 20 miles away and say, "Oh, isn't that bridge beautiful?" Here's the problem. They used to have a salmon run here. Once they put up these lights, the salmon population kept decreasing. And finally, a researcher from Oregon figured it out. The salmon, when they're faced with a light shield like this going into the water, won't cross the light. They just won't. So they stop here and just keep circling and die. So they never go upstream to spawn. They finally shut them off for 2 months when the salmon are spawning, and all of a sudden they've come back. So this, when it reached its low point, it now back to normal. I wish they'd shut it off completely. They haven't done that, but at least they shut them off during spawning season, which goes to show that species you would never think of are affected by light pollution are in fact affected. Birds. Anyone know about that Las Vegas, the pyramid there? I forget the name of that gambling place where the light shines off into space. It's one of the brightest lights. Yeah. Well, here's a dirty little secret. They actually have a team that goes around the base of it every morning to sweep up all the dead birds. And the reason is the birds see that and just fly around until they're exhausted and drop dead. Okay. I don't know why they do that, but they do. And basically they keep killing tons of birds every single night because of this idiotic light that does nothing. Mayflies, Susquehanna River in Pennsylvania. They put up a 4,000 K light above this. Look at all the dead mayflies instead of being in the water to make new mayflies and to become fish food. Same thing with canopies that are 4,000 K lights. Pollination. We need birds and insects to pollinate our food. If they're in decline, we lose pollinators. That's why beekeepers are now in such hot demand. They need the pollinators because we'll keep killing off all the natural pollinators. So it affects birds, fishes, insects, plants, mammals. Let me skip that. So here's one that I thought you'd be interested in. Right now, we have toxic algae in the Florida waters, right? I know it's off Fort Myers right now. Okay. So how can we combat it? One is to get the sugar producers to stop spilling so much fertilizer into the river that goes between you and just north of Fort Myers there. What's the name of that? Anyways, that's one reason that you get these toxic blooms. But the second reason is quite surprising. At night, zooplankton stay in the deep so that they don't get eaten. At night, they come up to the surface and they eat algae. That's their food. So why don't they come up and eat the red tide algae? They can eat them. If you have light pollution, even just a little bit, the zooplankton won't come up because they think it's daylight and they're exposed and will get eaten themselves. Okay. So part of the problem is we have light pollution on the edge of our coast, and that keeps the zooplankton from eating the toxic algae. Let that one sink in. So, well, I already talked about that. So let me go. I was recently involved in a responsible outdoor lighting at night. It's a meeting in Europe regarding light pollution, and they got some good stuff going on. Here is Saturn through my scope, and I'll stop there and answer any questions. By the way, if you go to my website, you can download many of the studies I just pointed out. Go to the light pollution, click on that, and you also have a lot of my, about 600 of my photos listed as well. So, questions?
I got a question, Mario. By the way, great presentation. I mean, it really, I didn't realize the evidence was so strong on the, on the health effects, and that this presentation was very enlightening. But the question I have, you talked mostly about, kind of the intensity of the lighting, right? Going from that, 2,700 to 6,000 range, and in any of these, ordinances or laws that were passed, changing that, did any of those laws also include controls or mitigation on directionality? I mean, and that's more of an astronomy kind of question, right? Is the light shining up, or is it shining down, or?
Yeah, that's two separate questions, but let me answer them one at a time. So it's just common sense that you shield the lights, and that's in 2009 AMA, which remains policy, and most people have accepted that it should be shielded so it doesn't shine in your eye. So that's pretty much a given. Okay. As far as controls, yes, that's becoming a thing. Those are more recent. And Europe, in fact, is mandating it in many countries where you don't have to have the lights on all night long, especially in rural areas. You have a sensor that sees the car coming several pole lengths away and turns on when it notices activity, turns off after a few minutes after the car passes. That's one type of control. Second type of control is dimming at night. Okay, Cambridge, Massachusetts, for example, put in 4,000K. People hated it. What they did is added controls. It only adds about 10% to the cost of the installation. So at 11 o'clock at night, it goes from, I think they put these 4,000K lights at 70% illumination, and they decrease it to 30% after 11 or 12, depending on the thoroughfare. So that's another type of control you can use that cuts down on electric usage and cuts down the intensity of light. Does that answer your question?
It does. Thank you. I wasn't sure when you were using the term shielding earlier in the presentation, if that's what you were referring. So thank you. Thank you.
I have a question on shielding also. You mentioned shielding to suppress the intensity of the light, which thereby also cuts down on the amount of the detrimental blue light.
Yeah, no, let me rephrase that. The shielding is not to cut down on those are three separate things. The shielding is to keep the light from shining in your eye. Why do we have a light? Think about this logically. The only purpose of a light is to bounce off something, bounce off the road, bounce off the car in front of you. Okay, if it doesn't bounce off something, okay, it's useless light. So if it goes horizontal and goes in your eye, constricts your pupil, that didn't help you see any better down the road because it didn't bounce off anything. The shielding is so that the light never goes above 80% of the horizon. So 90% would be light going completely across, and that's useless light that goes sideways because it's not helping you see the road. It's actually detrimental because it shines in your eye and constricts your pupil. So by shielding, that's what shielding is. The intensity is a separate matter. You don't want to overlight. Okay, it should be no more than moonlight or busy intersections, 2 to 3 times moonlight. Moonlight is 0.1 lux. Okay, so there's intensity, and you don't want to overlight, which the lighting companies bamboozle city councilors all the time. Well, you have 60 watts, we'll put up 60-watt LEDs. You save no electricity that way, and you have 4 times as much lighting as you had before, which leads to light pollution. Okay, and the third thing is CCT. That's the color temperature, and that's independent of the other two. The CCT, you want a low CCT, color correlated temperature, to cut down on blue light. So you want 3,000K or lower. I would say 2,700K or lower. 3 separate independent things you should control.
So that was a poor choice of words using intensity. I meant to refer more to glare, but the question I had is, can the shielding be also used to filter out the blue part of the spectrum?
Hawaii did that on the Big Island. For some reason, they couldn't get proper lighting, and some companies sold them. They're 4,000K lights, but they put yellow filters on the lights. That's not shielding. Well, it's shielding in a way,
Yeah.
but they put yellow filters, so it completely filtered out all the blue. And so if you're saying it in that vein, yes, they can be designed that way, but that inherently makes it inefficient. You're just taking away light rather than turning it into something useful. A better answer is to get a low CCT light. That way you get 100% of what you're paying for, as opposed to just filtering out a third of it.
Okay. All right.
I'm wondering, you've made a, you've presented that the lighting industry was extremely opposed to the low color temperatures.
Not all. I said Florida Power and Light and Duke Energy, North Carolina, are two of the worst.
I
The rest
meant
of the rest of the country, some are good and some are bad.
no, I don't mean today. I mean in the early, like in the
Yes.
early 2010 to 2015.
Yeah,
It sounded like they were almost uniformly opposed, and the rationale I heard was that they were slightly less expensive for the cooler temperatures.
correct. And they could buy them from China, 4,000K lights, incredibly cheaply. So, Siemens bought literally a shipload of lights, stored them in warehouses, and want to now sell them across the country. They bought them for pennies on what they were going to sell them for, and they were going to make huge profits. Okay. At the time, China didn't know how to make anything except 4,000K lights, and that was the cheapest source. That was the problem.
So it really was driven by the cost of the cool temperature versus the warm temperature.
It was driven by greed and corporate need to get as much profit out of all these contracts as possible.
So what is the remaining reason? Because you said now that there's negligible difference.
There is
So
no,
why is
why?
FPL, for instance, so
Part of the
opposed?
problem is they still have a huge warehouses full of 4,000K lights. They can't get rid of them. People are getting wise to them. So they sit there and they cannot sell them. So they sell them at a huge discount to unsuspecting small towns nowadays. So many rural cities who have no expertise in this will say, oh, well, this is a half price. We'll take them now. Or they're selling them to African countries who basically will take whatever they can get.
Okay. A Florida specific question. We have no laws. So for instance, in the subdivision where I am, probably 3/4 of the streetlights have no shielding. They are the old style, like fake gas lights, so that probably at least half of the energy is radiated upward, not just downward. There are no laws against that in Florida?
No. I'm having a meeting tonight with Diane Piera. She's from the Miami area. She's an activist in Florida. In fact, there's a current state law which she wants to discuss, which will is being touted as protection of the insurance industry for negligence on the part of homeowners, where it basically will say, I'm not making this up, this is what she wants to have a meeting about. In Tallahassee, there's a bill filed that basically says, if someone breaks into your house and you didn't have adequate lighting outside to protect your house, like the light will scare away the boogeyman, then you're liable and not the insurance company.
Wow.
Okay. So basically that will basically encourage every development to put up bad lighting so that they won't be co-liable for the break-ins. I'm not making this up. I have a hard time believing that would pass the legislature, but having spent time in Florida now, nothing surprises me.
I was going to say, if you're in Florida, the statement, you can't make this stuff up is prefaces a lot of things. It's just hard to believe.
So Mario, you touched on another question I had that I was going to ask, and that has to do with pushback from people claiming more lighting means more security. Now,
Yeah.
I've heard, I've read where there have been studies that show that isn't true. But I was wondering what your take
My
on that.
answer to that, if you're in a meeting where someone makes that claim, say, show me the study that says what you're saying is true. Because to this day, I keep asking the lighting companies when they say, well, you need it for security, show me a study that extra lighting gives you more security. They can't provide one because it doesn't exist. In fact, every time it's studied, it shows the exact opposite. Okay. Two great studies I'm going to mention. One is where they interviewed basically prisoners who broke into homes, said, why did you pick this house? Well, it had all these bright lights, and basically it's like a neon sign saying, I got expensive stuff. I'm afraid of you. Please stay away. Okay, those are the houses they target. You're basically advertising to the world is, I'm afraid of you, and I got stuff that's expensive to steal. Okay. The second great study is Chicago, I think it was around 2010, got this grant to light up all the alleyways because they had crime in alleyways. So they were going to light up every alleyway in Chicago. They ran out of money 2/3 of the way through. So they had 2/3 of the alleyways were overlit. 1/3 of the alleyways were not lit or poorly lit. University of Chicago decided this is a great way to study the crime situation. So they did. And after 2 years of studying and collecting all the data, what they found is crime rate where they put the lights went up by 30%. The crime rate where the lights weren't there stayed the same or went down. Okay. Published study, University of Chicago. Multiple other studies have shown the same thing. Criminals need to see like you or I. And if they're going around a dark house with a flashlight, you can see them. They could be standing under a floodlight and you can't see them. Okay.
Yeah, the HOAs around here, the usual statement is, in addition to security, is it's a safety issue because people out walking their dogs at night might trip over their shoelaces or the sidewalks or not see the alligator, hiding in the pond that they are, walking their bait on a string by, when they walk the little dog down by the edge of the pond.
Yeah, that's persistent fear of the boogeyman and is not based in reality.
It's just amazing. So, yeah.
Mario,
So nothing we can do about it, really.
Well, you can go to city council meetings and demand better lighting, demand that you follow with even the IES, which fought us tooth and nail this year, finally changed their stance and want responsible lighting. They actually fired the head of the one I debated in California. His name was Richard Liebel. I swear he was in the pay of the lighting companies because all he did was defend them. Anyways, he's the one that sent all the threatening letters to the AMA and me. I've saved a few of them. They got rid of them last year, and they have someone now in charge of the roads division who makes the standards, who actually wants good lighting, wants shielded lighting, wants lower CCT, and doesn't want overlighting. So all of a sudden, their topic this year, which blows me away after 5 years of nonsense, is responsible lighting for human health. That's the title of their annual meeting.
Well, yeah, they've decided that now they can make money by going back and replacing all the
That's correct.
the cooler lights with warmer lights.
The shitty lights.
The cost of the lights are the same. It doesn't matter whether you put up good lights or bad lights. They're essentially identical. Okay. They last as long. They use less electricity as much. So the only difference is choice now.
I swear that the smoking industry probably invested heavily in the how to quit smoking industry as well.
They did.
Mario, and maybe others, have you guys noticed that the automotive industry is increasing the color brightness of the lights in the cars, headlights?
And getting
That's a long
lower.
story. That's a long story. The street lights are under the Department of Energy. in Congress and in most state houses. The 40 years ago, the car industry got in a carve out for their headlights. They will, quote, self-regulate. So they're not under the Department of Energy. They have a separate, I forget the term, but anyways, they have a separate regulation governing them. And basically they govern themselves. So they can do whatever they want. In fact, I don't know if you remember a few years ago, I think it was not Volvo had, no, not, why am I blocking on the name of the company? Audi. Audi had an advertisement that they put up, they put in 6,700 LEDs, and they were advertising the fact that it was like the surface of the sun, turn the night into daylight. Okay. People thought this was great till they got them and they started causing accidents because people were blinded and they couldn't see the car coming at them. Okay, so they stopped advertising that and they had some liability issues. So, but it wasn't because anyone forced them to do it. They just didn't want to get sued. Okay, so unfortunately, headlights, there's DeSalva, he was a congressman from California who was in charge of the committee that regulated cars. He retired this past year. So I've lost track of who is in charge of that committee in Congress. But unfortunately, it's a separate industry, separate regulations, not under the Department of Transportation because they lobbied and got their own carve out.
Well, if we wait for Congress to save us, we're all going to die.
Right. I'm just giving you the best answer I can.
Yeah.
Yeah.
Well,
But I have noticed that, Tony, some cars, they don't have their high beams on, but their lights are just blinding you at night.
well,
Well,
I'm
and I
gonna
think
go-
some of it's aftermarket. I mean, they sell a lot of aftermarket stuff that probably isn't legal.
Mhm.
Yeah, they're 5,000K, most of the ones that are being sold, which are horrible, especially if you're an elderly driver and you get scatter in your eyes. You're completely blinded by those.
So why is like on Interstate 75, a lot of their lights are literally blue now? Are they failing in some way? Almost
Old
purple.
LED lights, as the coating deteriorates, may turn blue.
Yeah, because as you said earlier, Mario, right, they all start out as blue lights, right? Those
Correct.
high, yeah,
Well, if the
okay.
coating deteriorates,
Yeah.
it becomes more and more blue.
Yep, that makes sense. That makes sense.
Well, there was very, very interesting talk and discussion today, Mario. I want to thank you for sharing this information. And it's not just about, astronomy, it's about health, and that's kind of an important thing. And I live in a subdivision too. The people across the street put up all stadium lights. And now the people on this side are complaining that they can't see the lake at night. So, it's craziness. So anyway, thank you so much for that talk. Do we have any other final questions or comments before we sign out?
Thank you.
Oh, I
Great.
think we're good. Thanks, Mario.
Okay, take care.
Thanks, guys.
All right.
Anyway,
take care,
sorry I
everybody.
missed that meeting on Monday. For some reason I didn't get the newsletter for some reason. I don't know why.
The imaging one is always the third. Hang
Yeah.
on.
Yeah, but this one was delayed a week. I remember that now. But
Was it? Oh, I didn't know that.
Yeah.
Maybe it was.
Yeah,
Yeah,
because he
okay.
was away. But anyways, in the future, if you could just send out an email with the link, it would be very nice. I'm giving the talk on the 18th, so I will need a link at that time.
Yeah,
Take care.
okay. And I mean, he really, did you not get Michael's note like 2 days before that it was happening?
No, I
Maybe.
don't remember seeing it.
I'll ask Michael to make sure that you're on his list.
Okay, take care.
All right.